Greetings, mathematicians, and welcome to Filling and Wrapping 3.2. This lesson is all about area of circles. Now, you guys should have made your way through an iReady lesson all about circumference and area. The purpose of this video that I'm making is to quickly go over some of the major topics that were talked about in the iReady lesson regarding area of circles. So, let's quickly review what we know about the circumference. And we know that there are two formulas or two equations that we can use to solve for the circumference of circles. The first one is in terms of the diameter, where in order to find the circumference, you can take the diameter of the circle and multiply it by pi. This constant that we found, this ratio between the circumference and the diameter. That's what makes this so useful. We've also found that we could find the circumference given a circle's radius. But in this case, we need to multiply the radius by 2 in order to get to the same answer. So we come to this equation here, 2 times pi times the radius. And why is this? Because remember, the radius is half of the diameter, or the diameter is 2 times the radius, or 2 times the length of the radius. So therefore, we can write both of these equations to help us find the circumference of a circle. So this is a review, but it kind of gets us into the mindset of thinking about circles and their terminology. Okay, so now let's talk about some of the aspects of finding the area and some of the important topics that they talked about in the iReady lesson. All right, so one of the first major topics about area was they were trying to, I think one of the characters mentions, let's think outside of the circle. And what the characters had you do was literally draw squares to cover the area of the circle. What was special about the squares, though, was that the length of the side of the square was the length of the radius. Oops. So if you can go ahead and draw a square to your best ability there. It's a little lopsided, but I think you guys get the picture. Okay, more or less we have a square. And we are actually able to cover this square, cover this circle with a certain amount of these squares. So here I have 2 squares, still not enough to cover the area of the circle. Here I have 3 squares, still not quite enough to cover the area of the circle. And there I have 4 squares, which actually covers a lot more area than the circle. So we said 2 wasn't enough, 4 was too much. Well, in between 2 and 4 is about 3, and this is what the iReady lesson was trying to hint at. So let's go ahead and write a sentence about how many squares we need to cover this circle. So to cover the area of the circle, we need about 3 of these. I'm going to call them radius squares because the length of each side of the square is the radius. So that makes sense, radius squares. Okay, so to cover the area of the circle, we need about 3 of these radius squares. I hope you can make a connection here that it's not exactly 3, but there is a special number that is around 3 that will help us here. Think about it for a second. So this number that we need, I hope you said, was pi. That doesn't really look like a pi. Let me make that, I can make that much better. Is pi, right? We need pi number of squares. Right, we need pi's radius squares in order to cover the area of the circle perfectly. We'll also approximate this to about 3.14. Okay. All right, let's keep going. All right, and one other point before we move on, folks, is that we need to talk about the area of the square, right? The space that the square takes up. And we're writing this in terms of the variables we have here, in terms of the radius. So each of these squares has an area of r squared. Why is that? Because r times r gives me r squared. When we find the area of a square, we multiply the length times width, or the base times the height, right? In this case, the base and the height are both r, or the radius. So each of these squares is going to have an area of r squared. That's also why we could call them radius squares. All right, now let's move on to the next important topic. All right, another important topic that they bring up. Remember, we're trying to relate this circle to squares and rectangles, which we are very comfortable using. And what's really cool about the second point is that if you were to infinitely slice a circle into equal parts, if you were to keep slicing the circle in half and half and half and half and half and half, eventually you would get a rectangle. You could rearrange these pieces to form a rectangle. And that's what they were doing when they were slicing all of these, or when they were making this circle and slicing it into halves. Right, so one thing that they pointed out was that we needed to keep in mind that the circumference is 2 times pi times the radius, right? And this is the length on the outside of the circle. Right, so that red outline that I put in here, that is the circumference of the circle. And as you keep slicing these slices in half and half over and over and over again, eventually you're able to rearrange the pieces into a lovely, simple rectangle. Now, what is so awesome about this rectangle? Well, the bottom part of the rectangle I'm highlighting as red, and the top part of the rectangle I'm also highlighting as red. So immediately you should know that these two sides of the rectangle relate to the circumference. So this side is going to be pi times r, and this side is going to be pi times r. When I combine pi times r and pi times r, what do I get? I get 2 pi r, or the circumference formula here. Okay, and then we have one more piece of the puzzle here. How does this relate to my circle? How does this side of the rectangle relate to my circle? Well, this side over here on the left is going to be my radius, as well as the side on the right. So essentially what we're doing here is we are taking a circle and cutting it into infinitely small pieces and reformatting them so they look like a rectangle. Why? Because rectangles and squares are so much easier to work with. And if we can do this, then we can find out a lot about these different shapes. So, going back to the question, well, how do I find the area? How do I find the area of this rectangle? Well, now you should be able to tell me. The area of this rectangle, which just so happened to be a circle before, you're going to take the length times the width. So that's going to be pi times r times r. Let's simplify this a little bit. Well, I know that r times r is just r squared. So the formula that we use to find the area of a circle is pi times the radius squared. And there you have it, folks. This is the trusty, nifty formula we're going to add to our toolbox and use to help us on our practice.